Section: Introduction. We're diving into the world of language models, which are crucial for a wide range of tasks in natural language processing like few-shot learning, summarizing, answering questions, and more. Recently, the creation of these models has been mostly in the hands of a few big players who often don't share much about how they build these models. This is especially true for the data used to train these models, which is often described in very broad terms. This lack of detail makes it hard to understand how the choice of training data affects what the models can do and their limitations. This, in turn, affects both scientific progress and how the public interacts with these models. We're taking a different approach by focusing on openness and transparency. We're sharing a huge dataset containing 3 trillion tokens and providing tools so others can check, use, and build upon our work. Our goal is to make it easier for more people and organizations to get involved in researching and developing language models. Being open about the data helps developers and users make better decisions. For instance, if certain documents or terms are more common in the training data, the model tends to perform better on tasks related to those terms. Also, being aware of biases in the training data is crucial in certain areas. Having access to the training data is essential for studying how different types of data affect how models behave. This can lead to better ways of choosing and preparing data for training models. Our work supports research into various issues like how models might memorize data, handle duplicates, resist hacking attempts, avoid being misled by the data they were trained on, and trace back their outputs to the training data. To help with this, we're introducing the Data for Open Language Models Appetite, Dolma, a massive collection of 3 trillion tokens aimed at supporting research into training language models. We've gathered data from a variety of sources, including web pages, scientific papers, code from GitHub, books in the public domain, social media posts, and encyclopedic content. We've made sure that Dolma is not only large but also of high quality and diverse, comparing well with other datasets out there. It's already been used to train a new set of cutting-edge models called OLMo. Our contributions are twofold. First, we're releasing the Dolma Corpus, a huge and varied collection of data from 7 different sources, totaling 3 trillion tokens across 5 billion documents. This gives researchers a rich resource for training language models. Second, we're sharing the Dolma Toolkit, a set of powerful, easy-to-use tools for managing large datasets. This toolkit lets others replicate our work and create their own datasets for training language models. The rest of our paper is organized as follows. We start by outlining the principles that guided the creation of Dolma. Then we describe how we process the raw text, including steps like filtering for language and quality, removing duplicates, and preparing the data for training. We also discuss how we tested Dolma's effectiveness for training models and conclude with our process for making Dolma available to the public. In creating Dolma, we focused on 4 key areas: being open, aligning with previous work, ensuring the dataset is large enough, and reducing risks. By matching how other language modeling datasets are created, we make it easier for the research community to use Dolma and to study and critique current language modeling efforts, including those developed in secret. We followed well-established practices for choosing and preparing data, sticking to English to align with these practices and ensure our work is as widely applicable as possible. We also provide a detailed look at how both proprietary and open language models, like GPT-4 and Llama, are developed, sharing what we know and what remains a mystery. Section Summary. Language models are crucial for various natural language processing tasks, but the lack of transparency in model development, especially regarding pre-training data composition, hinders understanding of model capabilities and limitations. To address this, the authors released a dataset of 3 trillion tokens and tools for reproducibility, aiming to enable broader participation in language model research and help developers and users make more informed decisions. The dataset, called Dolma, is a diverse collection of 3T tokens from various sources, comparable in quality and diversity to other popular pre-training corpora, and has already been used to pre-train state-of-the-art language models. Section: Dolma should support training of large models. We believe that Dolma should play a significant role in training large models. It's been suggested that to train models optimally in terms of computing resources, there should be a balanced ratio between the size of the language model, measured in the number of parameters, and the minimum amount of training data required. Recent models that adhere to these scaling laws, like Llama 2, indicate that there's potential for further performance improvements by increasing the training data. Given this is a rapidly evolving field, we aim to compile a very large dataset, targeting 2 to 3 trillion tokens, to enable deeper exploration into how the size of the model and the dataset relate to each other. Dolma should also contribute to the availability of open datasets. The lack of access to both pre-training datasets and the corresponding language models has been a significant barrier for the wider research community. Only a few of the many models released recently come with their training data, such as T5 with C4, Bloom with Roots, and others. However, these existing datasets have limitations, which has led to the need for a new dataset like Dolma. While datasets like C4, Pile, and Falcon are high quality and have been useful for training language models, they are not large enough. Roots, although large and diverse, doesn't have a sufficient English-only portion for training models in English only. Red Pajama v2 meets our scale requirements but doesn't accurately reflect the variety of content sources that are typically used in creating the largest language models. Our effort is most closely aligned with Red Pajama v1, which was an attempt to recreate the Llama training data. We aim to go further by including a wider range of data sources, such as larger collections of scientific papers and online forums like Reddit, making ours the largest curated open pre-training corpus to date. We define openness as sharing the data itself and documenting the curation process, including the rationale behind our choices and providing open-source tools for others to replicate our work or create new datasets. This approach will enable researchers to develop their own data pipelines to refine Dolma or process their datasets. In curating Dolma, we are also committed to minimizing the risk of harm to individuals. Creating a pre-training corpus could potentially expose individuals to risks, either by making certain information more accessible or by facilitating the training of harmful models. To mitigate these risks while achieving our goals, we consulted with legal and ethics experts early on and made data design decisions based on their advice. We adhere to best practices, such as masking personal identifiable information, and take a balanced approach when opinions in the literature differ, for example, in identifying and removing toxic content. We also provide tools for requesting data removal. As the landscape of data and AI continues to evolve, we acknowledge that our decisions may not be perfect. However, we believe in compromising on certain desirable research artifact qualities, like model reproducibility, performance, and extensibility, in cases where there's a significant risk of harm to individuals. Even with these guiding principles, curating Dolma involves many complex decisions. Without a clear precedent to follow, we rely on two main principles to guide us. First, we use an evaluation suite developed as part of the OLMo project to guide our decisions during pre-training, aiming to improve a range of capabilities and tasks. However, we recognize that our evaluation suite isn't perfect and may not fully capture the benefits of adding certain data sources, especially after models have been fine-tuned with instructions. In such cases, we ensure that our decisions don't significantly impact the performance of any tasks in the suite. Second, we prioritize decisions that align with research directions that are of interest to our organization and other academic or nonprofit institutions. This doesn't necessarily mean maximizing performance on benchmarks, as many desirable dataset interventions may conflict with each other.